Today's topic is how to use dimensional analysis to solve complex conversion problems. You're going to want paper, pencil, and a calculator, and then we can begin. So what if I asked you to calculate how many milliseconds a student will spend in lunch during their high school career, assuming they have perfect attendance? Could you do that? Well, it would involve knowing how many days are in a school year, how many minutes are in a lunch period, how many milliseconds in a minute. And once you know those numbers, you have to figure out, well, which numbers should I multiply together and which numbers should I divide by? With dimensional analysis, we let the units guide us into where the numbers belong, and that makes it crystal clear when we should multiply and when we should divide. Let's see how it works. So with dimensional analysis, we're going to use conversion factors, and those are simply fractions or ratios of two units that are equal to 1. Now we know that in a fraction, if the numerator and the denominator are equal, like 5 over 5, that fraction equals 1. We can also set up fractions with different units that end up equaling 1. For example, if we have 4 quarters over $1, that fraction equals 1 because 4 quarters equals $1. And it doesn't matter if I put the 4 quarters in the numerator or if I put the 4 quarters in the denominator, 4 quarters are still equal to $1 and that fraction still equals 1. So we're going to use those conversion factors and set them up in a string so that if a unit appears in the numerator and the next conversion factor, we put it in the denominator, because things that are in the numerator and the denominator can be canceled out. And using this method, we're going to slowly move from the given unit towards the unit that we need our answer to be in. And then once we get the desired unit, we're going to multiply across the numerators and we're going to divide by the denominator. Same way, if you had this math problem, you would multiply the numerators together, multiply the denominators together, and then you would divide the numerator by the denominator to get your answer. To see how this works, we're going to do some practice problems with some made-up units, just some colors. And the first question is 20.0 red are equal to how many green? Well, we always start by writing down what we're given in the problem as our first numerator. So we have 20.0 red. Then we're going to look at the conversion factors. Well, over here in the color key are the made-up conversion factors for these colors, and we can see that there is one that says 6 red equals 1 green. We're going to write that as a fraction. Either we're going to have 6 red over 1 green, or we're going to write it as 1 green over 6 red. To determine which way we write it, we need to look at the unit we already have. We already have red in the numerator, which means we need to put red in the denominator of our conversion factor. So I want to write that conversion factor as 1 green over 6 red. Now since red is in the numerator and the denominator, we're able to cancel out those units, not the numbers that went with them, just the word red. And we can see that the only unit left is green, which is what our answer should be in. So we're done with conversion factors, and now we're going to multiply across the top. We have 20.0 times 1 green, that's what's left on the numerator, and the only thing left in the denominator is a 6. So when we multiply across, we have 20 divided by 6, which comes out to 3.33 repeating. Remember, in chemistry, we look at significant figures. 20.0, the number that was given to us in the problem, has 3 sig figs, so we're going to have our answer have 3 sig figs as well. So our final answer should be 3.33 green. Now, some of you may be thinking, well, I could have done that in my head, and maybe you could, but we're going to take a look at some more complicated conversion factors and see how we can use dimensional analysis to save ourselves time in our multiple step conversions. Now in our second problem, it says how many blue are equal to 2.0 brown, and we always start with the givens. 2.0 brown goes in the numerator. Do we have a conversion factor over here that goes from brown to blue? And as we're looking, we don't, but we do have one that goes from brown to green. So that's going to be the conversion factor we're going to start with. And since we already have brown in the numerator, remember we want to put the brown unit in the denominator. So we're going to write 3 green equal 2 brown, where brown is in the denominator. And then we can cancel brown out. And we're left with green, which is not our desired unit. Do we have a conversion factor that goes from green to blue? And we do not, but we do have one that goes from green to red. So we could either do 1 green over 6 red, or we could write 6 red over 1 green. To figure out which way we write it, we look at where the green unit already is. It's in the numerator. So in the next conversion factor, we want to put green in the denominator so we can cancel it out. And we're left with red as our unit, which still is not our desired unit. So we go back up to our conversion factors and we see we do have one that goes from red to blue. And since red is already in the numerator, in our next conversion factor, we're going to put red in the denominator. So we're going to write that conversion factor as 1 blue over 5 red. Cancel out the units and we're left with blue as the only unit, which is what we're looking for. So now if we take a look at what's left here, what have we not canceled out? We still have 2.0 times 3 times 6 times 1 blue over 2 times 1 times 5. Remember, if they're the same number in the numerator and the denominator, we can take it out. So we can take out the 1s and we can also cancel out the 2s. So we're left with 3 times 6 blue over 5, or 18 divided by 5, and that's going to equal 3.6 blue. So by using dimensional analysis, we were able to simplify this problem down to just a few numbers before we ever put anything in our calculator. Now that we understand the concept, we're ready to try some real units in our dimensional analysis. So how many minutes are in 2.50 weeks? Well, we always start with what's given, so the 2.50 weeks is going to go in the numerator. And then we need to come up with a conversion factor. And we probably don't know how many minutes in a week, but we know something in a week, like days in a week. So we want weeks to be in the denominator and the days to be in the numerator. So 7 days is equal to 1 week, and we can cancel out the weeks. We might not know how many minutes are in a day, but we know how many hours are in a day. Day is going to have to go in the denominator. 1 day is equal to 24 hours. Cancel out the days. Hours have to go in the denominator, so 1 hour is equal to 60 minutes. We've canceled out all the units except for minutes, which is what we're looking for. We're going to multiply across the top. 2.5 times 7 times 24 times 60 minutes, all over 1 times 1 times 1, and we're left with 25,200 minutes. So now it should be much easier to figure out how many milliseconds a student spends in lunch in their high school career. Typical student's going to spend 4 years in high school. A school year is 180 days. We're going to put 1 year in the denominator, 180 days in the numerator, and cancel out the years. Each day they spend 30 minutes in lunch. So 1 day in the denominator, 30 minutes for lunch in the numerator, cancel out the days. 1 minute is equal to 60 seconds. Minutes go in the denominator, seconds in the numerator. And then there are 1,000 milliseconds in 1 second. Seconds go in the denominator, milliseconds go in the numerator. So we set up all our conversion factors so we can cancel out the units. All that's left for our unit is milliseconds. So now we're ready to do the math. We're going to multiply across the top, divide by the numbers on the bottom. In this case, the only numbers in the denominator are 1s, and dividing by 1 doesn't change anything, so we can ignore those. And we end up with an answer of 1,296,000,000 milliseconds. So by using dimensional analysis, we take out all the guesswork about when we multiply and divide, because the units tell us where the numbers go, and any number that's in the numerator we're going to multiply, and any number in the denominator we're going to divide. Thank you so much for joining me. I hope to see you soon.